Okay, so this is a formula for angles in an acute triangle. So B, the side length B in that triangle equals C cosine A plus A cosine C. And if I remember, this was a little more difficult, but what do you want to do here?
Well, we do. Well, we could could try to use a formula that we already know.
Okay.
So I better use the sides.
Yeah, the little a, little b, and little c are the sides, and the big A and big C are the angles.
Well, let's see. We could try maybe using the law of cosines. So could get some sort of equation for that.
All right.
B squared is A squared C squared plus or minus 2AC cosine B. Oh wait. So maybe we could use this to find expressions for cosine A and cosine C and substitute them in, and then see if the equation simplifies slightly.
Okay.
So if we're trying to find cosine A, that means A squared is B squared plus C squared minus 2AC cosine of A.
Not quite.
Minus 2AB. Or BC.
BC. Yeah, there you go.
Well, let's see. We move B squared and C squared to this side. It's 2BC cosine A. And now, instead of just finding an expression for cosine A, we could find the expression for C cosine A and make the problem even more simple.
Okay, that's a good idea.
So we divide by negative 2b to get C cosine A.
All right.
So this whole thing becomes A squared minus B squared minus C squared over negative 2b. And we should get a similar expression for this, A cosine C. So again, using the law of sines, we get C squared is A squared plus B squared minus 2AB cosine C. We're going to do the same thing, minus A squared plus B squared plus C squared, negative 2AB cosine C, and then divide by negative 2b and get A cosine C over negative 2b. So we actually get the same denominator on these, which is nice. So we can write this as one expression. So add the minus A squared minus B squared plus C squared all over negative 2b. These cancel out, and the C squared cancels out. So we're left with negative 2b squared over negative 2b, and this simplifies to b. So since the equation equalizes this, this means it's true. Like always. It's true always. So that means our original equation was true.
Okay, nice. Wow, that's really great work. Cool. There was an interesting restriction, though, that it was restricted to acute angled triangles. So, why do you think that would have been the case? Why do you think they needed to talk about a restriction to acute angled triangles there?
Well, maybe it had something to do maybe cosine C. Well, maybe you could have a different angle C, and then cosine C could be the same.
Okay. Yeah.
So, that would be.
Yeah. So along the way, you were dividing only by b's, which is another one of the side lengths. So that should never be 0. So that shouldn't be a problem. Oh, we'll leave that as kind of a mystery challenge as to why they were saying just only talk about acute angle triangles. But that was really nice work because it looked like that. You've got the two same denominators, everything canceled. So maybe we should explore some obtuse triangles and see. Is it true? Is it not true? Maybe that'll be a good project for tomorrow. Okay, so let's go to the next one.